All right, but I'm going to just steer us away from this one because there's another topic that came up earlier on that got dropped, and it's a scary one. It was your arc length idea. We got sidetracked on the arc length, but you've asked a very important question. Look at these tracks. And I'm just picking points of intersection only because they're convenient points of reference for us. But between these 2 points on the track, now we got locked on at the beginning and end when we started about talk arc length earlier on, but now let's just focus on the arc length. Which piece of track went the furthest distance between those 2 points? Red is longer than the black. Between these 2 points, red is longer than the black. In fact, everywhere is the red longer than black.
I think so.
Think about a bicycle. As the bicycle rides on the ground, aren't those wheels rotating at the same rate?
Yes.
No.
They can't be.
Well, we can ask the rider, but when you were
Were you
riding-
rotating your wheels at the same rate as you were riding today?
Definitely not. I didn't feel like it at all.
This is an interesting question because if these wheels are both on the ground, both rotating at the same rate, aren't we sweeping out the same amount of circumference perimeter each time? In which case, all tracks should be the same length. Which was, I know is one that's the one I want to come back to and make sure we didn't drop that. Is that just wrong? What we're seeing right there?
No, because
Maybe not.
when he was wobbling, his black back wheel could almost be stopped as he's moving the front wheel to wobble.
Right.
Yeah,
Yeah, the front wheel moves faster than the back. You know, they rotate independently.
The back wheel, you can go around with the front wheel.
Ah, so you're saying the wheels don't need to be turning at the same rate.
Right.
They can kind of different.
Give me an extreme case where one wheel's really not rotating at all and the other wheel is actually rotating.
It's a circle. When you leave the back wheel fixed, then you do the circle.
Alright, so if I'm even, okay, extreme, if I pivot,
Yeah.
so basically the back wheel's not rotating, yet the front wheel is going to be sliding. So actually, I guess we've discovered the wheels aren't rotating at the same rate. Hence, you can't have one track being longer than the other.
Yeah.
Alright, this did perturb Galileo, by the way. Not that trains were invented in the 1600s, but he thought about train tracks. This is a classic paradox. I don't know if you noticed, but trains have double tracks and the wheels are double. So if you've got one great big steel wheel that goes on the bottom track and another steel wheel that rides on the center track, and they're both stuck together, glued on. Both wheels are just one fixed, moving on double tracks. Makes them very stable, these trains. If you think about it, as this train goes along, one full rotation of the big wheel, that is, roll, 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 roll. So that's one circumference of the big wheel. It's a big circumference. What's the little wheel doing? What's this point doing as it rolls one big circumference? But if this point's just done one great big full turn and ended back up here, what's this point having done? One full turn and end up back there. In which case this length matches the circumference of the small wheel. And this length here matches the circumference of the big wheel.
Okay, that's
Well, yes.
very uncomfortable.
That through Galileo.
But the center of the little wheel is moving, right? The little wheel is not.
So is the center of the big wheel, isn't it?
It's carried. The little wheel is carried by the big wheel. If that helps.
So there's no slippage on either surface.
So it's not really rotating on its own.
Oh, if they're glued together.
I guess my question right now is, they're glued together, those wheels are glued together. Is this perturbing or not perturbing?
Extreme. I'm feeling very uncomfortable with this.
I mean, we did have that paradox here, but you managed to resolve it here. And here's the paradox in another form. How do we resolve it there?
Well, everything's rigid, so the angular velocity surely has to be the same, doesn't it?
That's true, those two wheels are stuck on each other, so they've got the same angular velocity. Absolutely. They both do one full turn in whatever that time it was.
Yes. So maybe
Yep.
the thing, the invariant isn't the invariant, the kind of thing that doesn't change is the angular velocity. That's the thing to focus on.
Okay, angular velocity is not changing.
Now I feel
Therefore,
more-
those lengths are the same. Excellent.
Well, that's so much better.
Somehow. Yeah, I feel great.
Yeah, you definitely don't want the two tracks touching.
Two tracks touching.
We're back to the unicycle again.
The point on the wheel is not moving on that straight line. It follows a curve. And the fact that the two curves are different lengths can be fine even if the horizontal distance is the same.
Actually, I wish I had a model here of this. But is it true when something rolls along the ground, all I'm really doing is unrolling the circumference of that wheel?
Yeah.
I know that point actually is doing like a curve like that. But in terms of the length, isn't this length the circumference of the wheel? And do it for the big one, would that length also be the circumference of the big wheel?
Yeah, both of them can't touch at the same time.
Yeah, this is perturbing. Do you want to be kept awake for the next few nights?
Yes.
Alright, so I'm going to leave that be then.
No, give us another one.
I'm going to leave that
Like
be.
a little more.
It kept Galileo awake for a good number of nights.